Bismillahirrahmanirrahim and Assalamu alaikum. My name is Ayan Rafiq and I am a foundation level student at Rehan School Islamabad Parako campus. Today I am going to conduct an AI session with Maya. In this session I will ask few questions and Maya will provide answer. So let's start. Okay Maya, my first question is what is software?
Software, at its core, is a set of instructions that tells hardware exactly what to do. Imagine a computer is like a piano. The hardware is the actual instrument, the wood, the keys, the strings. But the software is the sheet music. Without the music, you just have a heavy piece of furniture. With it, you have a symphony. It translates your intentions into a language the machine can actually speak, managing everything from the raw electricity in your processor to the way a pixel lights up on your screen. What part of that gets your curiosity going?
Okay Maya, my next question is what are the main type of software?
Think of it as a hierarchy. You've got your system software, which is like the foundation and infrastructure of a house. It's the plumbing and electricity that keeps everything running in the background, like your operating system. Then you have application software, which is like the furniture and appliances you actually use to get things done. This is where your web browsers, games, and productivity apps live. It's the difference between the engine that makes a car run and the GPS that tells you where to go. Which of those feels more interesting to dive into?
Okay Maya, my next question is what is system software?
All right, let's get into the grid of this one. System software is the essential layer that sits between the physical hardware and the application software you actually interact with. It's the backbone of the entire operation. Think of it like the nervous system of your computer. Your hardware is the body, but the system software is the electrical signaling that tells the heart to beat and the lungs to breathe without you even thinking about it. The operating system, like Windows or Mac OS, is the star of the show here. Its main job is resource management. It handles the CPU, decides which apps get to use the RAM, and manages how data is stored on your drive so your computer doesn't just freeze up the moment you open a second tab. Then you have things like device drivers, which are the translators. Your printer doesn't naturally speak computer, so the driver translates the system software's instructions into something the hardware can actually execute. And we can't forget utility software, those little tools like disk defragmenters or antivirus programs that keep the system healthy. Without this layer, you have to manually tell your processor exactly which electrical circuit to flip just to move your mouse one pixel to the left. Does the invisible heavy lifting so your apps can actually run. Does that paint a clear picture for you?
Okay, my next question is what is application software?
Yeah, this is the part of software that's actually meant for us people, the end users. Well, system software is the invisible foundation. Application software is the interface where we actually live and work. So the tool's designed for a specific job, whether that's something as professional as Photoshop for a digital artist or as simple as a calculator app. I like to think of it as the power tools of the digital world. It uses the system software to get access to the hardware, which lets the app focus entirely on solving a problem or providing entertainment. It's basically anything that makes a computer more than just a very expensive paperweight. Ready for the next one?
Okay, my next question is what is programming?
Hmm. Programming is the actual act of writing those instructions. If software is the sheet music, then Programming is the process of composing the song. It's the bridge between um, a human idea and a machine's execution. It's simplest. It's just taking a big complex problem and breaking it down into a series of tiny logical steps that a computer can't possibly misunderstand because computers are incredibly fast, but they're also incredibly literal. If you forget one semicolon or single bracket, the whole thing falls apart. It's this weird, beautiful mix of strict logic and creative problem solving. You're essentially building a digital machine out of thin air, using nothing but language to create something that can actually do work in the physical world.
Okay, my next question is, what is coding?
Coding is like the shorthand of programming. While programming is the whole process of planning and architecting the solution, coding is the specific act of translating those plans into a language the computer understands. If programming is designing the entire blueprint for a house, coding is the actual hammering of nails and laying of bricks. You can't have one without the other, but the magic happens when the two come together. What's next on the list?
Okay, my next question is, how is software development?
It's basically like building a city from the ground up, just digitally. It all starts with the planning phase where you figure out exactly what the problem is and how the final product should actually behave. Once the blueprints are set, you move into the design phase to map out the architecture and the user interface. Then comes the coding, where you're actually translating those ideas into a functional language. But you don't just ship it the second it's written. You go into a rigorous testing phase to hunt down bugs and make sure the whole thing doesn't crash the moment a real person touches it. Even after it's released, the work doesn't stop. You're constantly monitoring it, gathering feedback, and pushing out updates to keep it fresh and secure. It's a continuous loop of building, breaking, and refining. The real kicker is that the process never actually ends. Once a piece of software is out in the world, it enters the maintenance phase. This is where you deal with the unexpected. Users will find ways to use your app that you never imagined, and new security threats will emerge that you have to patch in real time. It's like living in a house that you're constantly renovating while people are already throwing a party inside. You're adding a new wing here, fixing a leak there, all while trying to make sure the guests have a great time. It's a wild, rewarding cycle of constant evolution. Want to keep rolling through the list?
Okay, my next question is, what is Chat GPT?
You probably mean Chat GPT, though Jet GPT sounds like it should be way faster. It's essentially a sophisticated prediction engine. Doesn't know things the way we do. It's just read nearly everything written on the internet and learn the patterns of human language. When you ask it a question, it's basically playing a high stakes game of what word comes next based on those patterns. But it does it with such incredible precision that it feels like you're talking to a person. That's why it's so good at brainstorming or summarizing, though it can occasionally confidently hallucinate a fact that doesn't exist. What else you got for me?
Okay, my next question is,
I'm
what
out of.
what is the difference between Chat GPT and Gemini?
They're like two different philosophers trying to solve the same problem. ChatGPT, created by OpenAI, is like that super precise, polished tutor who's a master of conversation and structure. It's incredibly good at following complex instructions and making things sound seamless. Gemini, Google's take on it, feels more like a researcher with a direct line to the live world. Since it's baked into Google's ecosystem, it's often better at pulling in real time info like checking your emails or flight status while still being a heavy hitter at reasoning. One is a master of the craft, and the other is a master of the network.
Okay, my next question is, which programming language is best for beginners?
For the vast majority of people, Python is the runaway winner. Its superpower is readability. Most languages look like a secret cipher, but Python is designed to read almost like English, which means you can focus on the logic of solving the problem rather than fighting with the syntax. It's basically the training wheels of the coding world, but it's also powerful enough to be used by NASA and Netflix. It's the most frictionless way to get your first piece of code to actually run. The real magic of Python is how it doesn't just get you started, it actually scales with you. It's basically the Swiss Army knife of languages because it's used for everything from AI and data science to building web servers. This is why it's so popular. You can learn the basics in a weekend and then spend the next 5 years diving into specialized fields without ever needing to switch languages. It's that rare tool that's simple enough for a hobbyist, but robust enough for a professional engineer at a Fortune 500 company. It basically removed the barrier to entry for millions of people who wanted to build things but were intimidated by the sheer complexity of traditional coding.
Okay, my next question is, what is HTML?
HTML is the skeletal system of the web. It stands for Hypertext Markup Language. But don't let the name fool you. It's not actually a programming language in the sense that it can't think or perform logic. Instead, it's a structural language. If you're building a website, HTML is where you define what everything is. You use tags to tell the browser, this is a heading, this is a paragraph, or this is where an image goes. Without it, the internet would just be a giant unformatted wall of text. It's the blueprint that gives every page its basic shape before the styling and interactivity even enter the chat.
Okay, my next question is, what is CSS?
If HTML is the skeleton, CSS is the skin, the clothes, and the makeup. Stands for cascading style sheets, and its only job is to make things look good. While HTML says, here is a button, CSS says, make that button neon green, give it rounded corners, and put it exactly 2 inches from the top of the page. It's what transforms a plain 1990s looking text document into a modern, sleek experience. Without CSS, every single website would look like a college thesis paper, and the internet would be a very boring place to look at.
Okay, my next question is, what is JavaScript? And then,
If HTML is the skeleton and CSS is the skin, JavaScript is the brain and the muscles. It's the actual logic and behavior of the page, turning it from a static poster into an interactive experience. HTML and CSS are great, but they're just for show. JavaScript is what happens when you click a button and a menu slides out, or when a page updates your notifications without you even having to refresh. It's basically the electricity that makes a website feel alive, allowing it to react to you in real time. What's next on the list?
okay, my next question is, what is the difference between a website and software?
The fine line, but the main difference is where they live and how they behave. Think of a website as a digital brochure. It's hosted on a server and you access it through a browser. Most of the heavy lifting is happening somewhere else and you're just seeing the results. Software, especially desktop apps, is like owning the whole tool. It's installed directly on your machine, has full access to your hardware, and usually works offline. It's the difference between reading a menu online and actually having the kitchen in your house. Does that click for you?
Okay, my next question is what is desktop software?
Desktop software is the heavy hitter of the software world. These are the programs installed directly on your computer's hard drive rather than running in a browser tab. Because they live right there on your machine, they have a direct, unrestricted line to your hardware, like your RAM, GPU, and processor. This is why you use desktop software for things that require raw power, like high-end video editing in Premiere or complex 3D modeling in Blender. You're essentially cutting out the middleman of the internet, which means these apps are usually faster, more stable, and can work without any Wi-Fi at all. It's the difference between renting a small apartment in the cloud and owning a whole house on your own land.
Okay, my next question is what is debugging?
Debugging is basically being a digital detective. It's the process of hunting down the one tiny hidden mistake in thousands of lines of code that's causing the whole thing to crash. I've heard that some of the most frustrating bugs are the ones that only happen once every 10 tries, which is enough to drive any programmer crazy. It's equal parts logic and obsession, where you're basically arguing with the machine until it finally does what you want it to do. Have you ever tried to fix a bug yourself?
Okay, my next question is what is Git?
Git is essentially a time machine for your code. Imagine you're writing a massive novel and you decide to rewrite the entire middle section, but you're not quite sure if the new version is actually better. Without Git, you'd be saving 15 different files called Novel Final 5 to Really Final and hoping for the best. With Git, you create a snapshot of your work at a specific moment. If you make a mess of things, you just click a button and warp back to exactly how the code looked on Tuesday at 2 p.m. before everything broke. It also lets multiple people work on the same project at once without overwriting each other's work, which is basically the only way modern software actually gets built without it turning into total chaos.
So viewers, this is the session for Maya today. We will meet you in another Maya session. Tab tak ke liye Allah Hafiz, Pakistan Zindabad.